Experimental designs. Students will be able to explain the purpose of blocking and randomization in an experiment. The second objective we'll address more in person in the next class. Students will be able to design an experiment appropriate to a given research question and its context. At the end of the previous lesson, you got a glimpse of how you can design an experiment simply through a diagram. On the AP test, you may be asked to design an experiment on one of the 3 response questions. So let's delve in deeper and give you a chance to get some practice. Let's consider the following research question. Does the amount of time spent on Facebook affect an individual's happiness? Before we get into the nitty-gritty of this experimental design, just based on this question, I'd like you to consider the following. What are the explanatory variables, the response variables, and the experimental units? Go ahead, pause the video, and see if you can come up with an answer before I show you my solution. Our explanatory variable is Facebook usage. We can also call this a factor because when setting up a treatment, we might actually include more than one variable, a factor, in our treatment. The amount of time actually spent using Facebook would be the level of that factor. And we're going to look at what we decide on our levels for this experiment. Our response variable is going to be happiness, and we'll think about how we're going to measure happiness for this experiment. And our experimental units, we're going to have a human subject. For our first experimental design, we're going to do a completely randomized design. Now remember, one of the key principles of experimental design is that there must be random assignment. And so in a completely randomized design, experimental units are assigned to the treatments completely by chance. So again, here's our research question, and I'm going to write out an experimental design, and hopefully you should be taking notes and writing as you follow along. So for this experiment, let's say that we have 3 treatments, and I'm going to write out what each treatment is. We have treatment 1, which will be 5 minutes on Facebook daily. Treatment 2, one hour on Facebook daily. And treatment 3, 3 hours. Oh, sorry, not 3, 2 hours on Facebook daily. Okay, so again, our explanatory variable, our factor is Facebook usage, and the level is exactly how much time our experimental units, our subjects, going to be spending on Facebook. Okay, so let's say that we have 120 volunteers of men and women aged 16 to 49 who decide to participate in this study. They all already have Facebook accounts, but they've been screened by the researchers and have been determined to use social media moderately. And for the purposes of this study, we can say that the volunteers do not have access to any social media on their devices, only when they come into the research center to participate in their treatment. So let's look at how we would design this. The following is going to be a completely randomized design that we just talked about and defined. We start with our 120 volunteers. We are going to, of course, use random assignment. To break these 120 volunteers into 3 groups. So we have group 1, group 2, group 3. Each group will have 40 volunteers. Now, let's say that everyone in group 1 will receive treatment 1. Everyone in group 2 will receive treatment 2. And everyone in group 3 will receive treatment 3. Now what's going to happen next is that we have to measure our response variable. Remember, we said our response variable is happiness. So let's say that this is a psychology experiment, and a psychologist is going to interview each of our volunteers and assign them a happiness rating on a scale of 1 to 10. So we can say in this next step, interview and rating. On happiness scale. So this step will occur for each of these treatments. I'm not going to write it twice. I'm just going to put these marks to indicate that it's the same step that's happening. And then finally, our final step, once we have calculated and measured our participants' happiness, is to compare results. Is there a difference in the happiness scores for people who receive treatment 1, treatment 2, or treatment 3? Did the amount of time spent on Facebook actually affect individuals' happiness? One important thing to note before we move on is that it isn't enough to just say that random assignment was done. You actually need to take time to explain exactly how random assignment was done. So we've covered a variety of methods on how to randomly assign or randomly sample, and so I'm going to talk about one method here, and you want to make sure that whatever method you come up with, it makes sense for the research question or the context they've given you. It says assign each volunteer a unique number. The numbers will be randomly scrambled by a computer. First 40 numbers and their corresponding subject belong to group 1, the next 40 numbers to group 2, and the last 40 to group 3. Simple enough, and that's all you need to do, but you have to explain how you will do random assignment. Now I want you to consider the overall experimental design. Besides Facebook usage, are there any other variables that might affect happiness? Of course there are. We could say exercise, relationship status, whether someone has pets, food, etc. So there could be a bunch of things that could also change or affect the response variable, in this case happiness. With so many variables, how can we be certain that Facebook is responsible for variations in the response variable? Think back to what we've talked about in previous lessons about the basic 4 principles of design. Pause the video, write down your response, and then we'll come back and debrief. The key principle of experimental design at play here is random assignment. Remember, random assignment one of the basic principles of experimental design ensures that each of the 3 groups should look roughly the same and be representative of all the volunteers. With random assignment, we should see a little bit of each type of person in each group. With possible variables that might affect the response variable balanced across all 3 groups, we expect the differences we detect in the response variable to actually be due to the treatments. So we've balanced all the differences across the groups, and therefore the variation that we're seeing, we think will actually now be due to the treatments. Let's say researchers decide that they believe individuals who were accustomed to posting on Facebook might respond differently to the treatment from people who rarely post, but mostly browse Facebook. In this case, researchers would carry out a randomized block design. So here it is. A block is a group of experimental units that we know to be similar in a way that we expect will affect their response to treatments. A randomized block design means that within each block that we create, random assignment must be carried out separately to each of the experimental units. Let's look at what a randomized block design looks like for our research question. Our 120 volunteers would be divided into 2 blocks, posters and non-posters. Let's say that we have 30 posters and 90 non-posters. And then, with random assignment, within each block, experimental units or our subjects would be assigned to each treatment. Ultimately, the purpose of blocking is to reduce variability so that we can see the effects of each treatment in each of the blocks. Remember, each of the blocks are homogeneous, which means that they're very similar in some way, and we expect them to react more or less the same to the treatments. So there are 2 key points that I want you to take away from today's lesson. Experiments are randomized to reduce the effects of unknown variables on the response variables, and experiments use blocking to reduce the effects of a known variable on the response variable. With blocking, we isolate the variability due to each treatment. This stuff is pretty tricky and confusing, so feel free to post questions and answer discussion in the comment section below. For your final assignment for today's lesson, or for your homework, take time to answer the following question. It's just a basic summary because I know we've been dealing with complex ideas. What is the difference between a completely randomized design and a randomized block design? Take time to write thorough answers. This will be a launch pad for a discussion in class tomorrow.